Good morning, good afternoon, and good evening, everybody. My name is Mohit, and I would like to welcome you all to this webinar on nVent leak detection and location systems for commercial and infrastructure applications. I'll start by giving a few guidelines about this webinar. So all attendees will be on default mute mode throughout the presentation. Question and answers have been kept at the end of the presentations. And if your questions are unanswered, we will answer them personally. I also request you to write your questions in the chat box, which is there in the GoToWebinar window, and we will answer them during the question and answer session at the end of the webinar. Please also note that this webinar and the recording and the presentation of this webinar will be shared with all of you after the end of the session. So let me begin about talking about our company nVent. The mission of our organization is to connect and protect our customers with inventive electrical solutions, and we firmly believe that safer systems ensure a more secure world. Talking of our products, we have three segments with a dynamic range of product offerings, starting from enclosures. In the enclosure segment, we offer electrical and electronic enclosures, data center and networking solutions, advanced cooling and climate control solutions under the brand name of Hoffman and Schroff. The second segment that we have is electrical and fastening solutions, wherein we have cable pathway installation systems, power and data resilience solutions, surge and lightning protection solutions, and prominent brand name under this category in this segment are Erico, Caddy, Lenton, etc. The third segment is thermal management, and the key product offering here is electrical heat tracing systems under the brand name of RAYCHEM, underfloor heating, fire-rated wiring, and liquid leak detection systems for industrial and infrastructure applications, including commercial. So if you look at the road to nVent, we have a century of innovation, in fact, more than a century of innovation. Back in 1903, Erico was founded, which is a part of our electrical and fastening solutions group. And as the century progressed, many innovations happened, many acquisitions happened. And more prominently in 1950s, RAYCHEM was founded. RAYCHEM pioneered in polymer technology and invented electrical heat tracing systems and leak detection systems, and went on to become global leaders in this technology. The process of acquisition continued over the century until very recently in 2020 and 2021. We have acquired companies like Eldon, WBT, Winkler, and CIS, which was just a few months back. So nVent is a fast-growing electrical solution company with inventive solutions for our customers. I'll move to the topic of the day today, which is liquid leak detection systems. And we can very proudly say that as nVent, we are global leaders in liquid leak detection technology. And what we offer is a wide range of solutions for different applications. We have got solutions for detecting water leak in data center server rooms, in intelligent buildings, overhead pipelines, chilled water pipelines. So anywhere water should not be present in an indoor area, we have solutions to detect water and also locate the location where the leak has happened. Likewise, we have solutions for fuel leak detection systems for commercial applications like diesel generators and pipelines. We do fuel leak detection system for fuel systems at airports, industrial tank farms. We have also got a category of chemical leak detection system for various applications in petrochemical, pharma, and other industry, wherein we detect acids, solvents, and different types of chemicals as long as they are in liquid state. Last but not the least, we have solutions for environmental spills like hydrocarbon leaks on pipelines, etc., whether they are buried pipelines or overhead pipelines. So we are a comprehensive liquid leak solution provider for different applications, ranging from commercial to infrastructure to industrial as well. 2020 marked a very special year for us because this year we celebrated 10 million meters of our RAYCHEM liquid sensing cables installed worldwide. Being the manufacturers or inventors of this technology, this was a significant milestone that we achieved, and 10 million meters with thousands of installations all across the world was a big reason for us to celebrate. Talking a bit about RAYCHEM technology, RAYCHEM was the first manufacturer to introduce patented liquid leak detection technology. Tristic was the brand name which was given to this technology. The system was designed to monitor leaks 24/7. Once the system was installed, it was in operation, and if there was any leak, it would detect. And with pinpoint accuracy, up to an accuracy of plus minus 1 meter, it would sense and give the location of the leak had happened. Further to that, the system was designed to carry out any remedial action or mitigation plan in case a leak was happened. With this technology manufactured in the United States, our headquarters is in Redwood City in California. We have thousands of installation in different applications worldwide, and all our products are carrying international approvals like UL, FM, VD, etc. And all our products conform to these international standards and represent the best-in-class technology. I'll start by giving you a small overview on what we do in commercial and infrastructure buildings for water leak detection system. Data centers is a big applications for water leak detection systems, and let's understand what is it in for leak detection in data centers. Well, water is a beautiful thing when you see it outside, but certainly not when it is in your data center. If water would come indoor into your data center, it would certainly be a problem. And many facility managers today are getting more and more concerned because water is used to cool down the data center. Leakages of water have caused real hazard in various data centers. So water leak detection systems have been gaining a lot of prominence over the last 1 decade in several upcoming projects and data centers. Of course, nobody would want water ingress and their data center to shut down, resulting in data loss, stopping of systems, etc. So when we talk of water leak detection systems, where can water leak come from, or what are the potential sources or areas in a building where water leak can happen? If you look at the anatomy of a building, water is an essential part of any building, and many services in a building today use water for various activities. And water leak can happen anywhere, interfere with the electronics, equipment, or important artifacts kept in the building, books, etc., and cause damage. So typically, water leak detection system today is used in data center server rooms, raised floor areas, because the area below the raised floor normally is inaccessible. And if water ingress happens there, typically in a data center facility, it normally goes unnoticed. So it is advisable to have a water leak detection system there. Rack equipment, control rooms, trading rooms, executive offices, telecommunication sites or typically cell sites or towers where telecommunication equipment are kept, piping networks which run through buildings, operation theaters in hospitals and intensive care facilities, and any other high-value space where water leak should not be present becomes an ideal place where a water leak detection system should be installed. And if you look at a typical data center facility or a data center space, where can water leak normally come from? It can come from within the ceiling because of some leakages in the piping. It can come from within the room. This is the biggest source of leakage because air conditioning and cooling is an integral part of a data center. It is extremely important to keep the system cool, and water is an important component in that. So leakages within the cooling system can cause severe water ingress. So that is another source. Janitorial services within the floor voids, heating and cooling system, drains, sprinkler systems, flooding adjacent rooms. So there are various potential sources from water ingress, from where water ingress can happen in a building. And what we have is a sensing cable-based technology wherein we install sensors in areas where water should not be present. And when water comes in contact with those sensors, it is immediately intercepted and notified on the control panel that there is a water present. So typically in a data center, we would install the water leak sensing cable on the true floor below the raised floor along the perimeter of the room, so that in case water ingress is happening, it comes in contact with the cable. The cable is connected to the control unit, which is the brain of the system. The control unit is continuously pinging the sensing cable and sensing for presence of any water. The moment water touches it, in a space of few seconds only, 2 to 3 seconds, signal is communicated to the control unit that water is present. We get to know that water leak is there along with pinpoint location of where the leakage has happened. These sensing cables are typically put onto the roof floor with the help of hold-on clips. and they are installed in a way that they can seamlessly stick to the surface and come in contact with water whenever water leaks. Depending upon the type of hazard present, if there are pipings which are running underneath the roof floor or above the false ceiling, we can design a water leak detection system. We can also install water leak detection system in the intermittent space between the perimeter of the room, provided there is a potential water leak hazard present in there. So designing of the system depends upon the threat perception from where the water leak can come in, and accordingly laying of the sensor is chosen. So talking of applications, storage areas, archives, and museums are places where water leak detection system is normally installed. It can be installed on the ceiling, it can be installed on the floor. Normally, HVAC units, drip trays, and drip pans are places where water leak detection can be installed. Office overhead AC leaks, normally which go unnoticed because of false ceiling designs that we have these days. We can place sensors, sensing cables, and probes on these drip pans and detect presence of leaks. Shafts is another example. Service columns in a building, we can wrap the sensing cable along the shaft as shown in this image. The sensing cable is wrapped at the bottom of the shaft, connected to modules, and then these modules are connected back to the main control unit. In case any water dripping is happening along any of these pipes, it comes in contact with the sensor and is notified to the panel through the module. We also get to know the exact location so that necessary remedial action is carried at the point of leak. These are some more illustrations of where water leak detection system can be installed. This is a horizontal pipe run and we have a drip tray beneath it. We can put a sensing cable in a drip tray beneath the piping network. In case there is no drip tray, we can install the sensing cable at the bottom of the pipe and we can strap it with the pipe so that in case there is any leak, the sensor can come in contact with it and give off an alarm. HVAC drip pan, this is the most sought after application for leak detection in commercial spaces because air conditioning units, they tend to leak at some point in time. So these drip pans do have an application where we install probes or sensing cables for sensing water leaks. Suspended pipes, typically used for sprinkler systems, hot water and chilled water pipes for water transmissions in building. We have water leak detection sensing cable with a special braid on top of it for these applications so that they can be strapped at the bottom of the pipe and they can be wound on a vertical riser as well with the help of a tie wrap. So these are real site installation images of some of our water sensing cables which have been installed below the overhead pipes. They've been strapped and in case water leaks, they come in contact with this sensing cable and the control panel will exactly know the location where the leak has happened. Underfloor areas I've already explained, but this illustration clearly says that the sensing cable can be installed on the perimeter of the room and on the false ceiling as well and connected to one control unit. Pipe and trench runs in a building where water ingress is there, we can install our sensing cable. Chemical storage areas, as I said in the earlier part of the presentation, that we've got solutions for different chemicals, like if you're storing acids, bases, ketones, or any kind of chemical which is conductive or non-conductive in nature. We can have sensors installed in those areas where we are storing these kind of chemicals, and whenever these chemicals comes in contact with the cable, we get to know the leak and the location, that leak and location of the liquid where this has happened. So going back to data centers, so what are the potential sources? I said about air conditioning units, chilled water pipelines, plumbing and condensation lines. So clogged drains, sprinkler system, and building leaks. These are the potential sources which cause leaks in data centers today. And we can all understand that the damage from this leak could be business disruption, damage to expensive equipment, cleanup costs, and the most precious of that is data loss, which sometimes is absolutely impossible to recover. So it's been advised by various designers, consultants, etc., to have an effective leak detection systems installed in these areas so that these kind of incidents don't happen. Let's have a look at the equipment which is involved in detecting leaks. So talking at a sensor level, we have a wide range of sensors which are used to detect conductive liquids, namely water. We have sensors for laying directly on the floor, TT1000, the yellow sensing cable which you see on the left. TT1000 OHP. OHP stands for overhead pipe. This has been designed to be installed below the overhead pipes. We have OHP thin, which is same as TT1000, but it is thinner in nature. This has been designed to be embedded inside the insulation of chilled water pipelines. And we have another cable called TT3000, which is for aqueous chemicals, which are conductive in nature. So these are the sensors which we have in category 1 for detecting water leaks in different applications in a building. Depending on the applications, we have also got probes, or we call them point sensors. These are used for applications where water is normally collected, like pits. Imagine a building which has got multiple lifts, and water ingress happens at the bottom of the lift pit. So we can place one of these point sensors at the bottom of the lift pit, and in case water leak happens, it comes in contact with this one of these sensors, and it is then relayed to the control panel the location of the leak. So all these instruments ultimately communicate to the control room equipment, and in the control room we have the main control panel. We have the latest touchscreen control panel. This is one amongst the various control panels we have got. This is the latest contemporary technology which can monitor up to 250 circuits, or we call them SIMs, sensor interface modules. It displays all the channels of leaks. If you have 250 channels, it will display all of them parallelly. It comes with a 12-inch touchscreen interactive display with all system parameters, extensive data logging up to 5,000 events, and third-party interface on Modbus RTU and TCP. And it has also got inbuilt email options, etc., in case remote notification of leak needs to be done. It is you can customize this panel in different ways. It comes with in a standalone mode, and it can come with built-in SIM modules as well. It's a UL listed control panel having all necessary approvals. We've also got sensor interface modules, which are normally installed in field, which are different types depending upon the application that we are working upon. We have got the one which is called TTSIM1, which can go up to 1.5 kilometers, which is normally used for long line applications. Typically, this is used for fuel leak detection applications. The other one is TTSIM1A, which is in middle, which comes with LED indications. This will give us the indication that there is a leak somewhere in the system. It can connect to the main control panel where the exact pinpoint location will be displayed. It takes 150 meters of sensing cable, and quite widely used in water leak detection applications as a standalone device or when connected with the main control panel. And the last one, which comes with display, is TTSIM2. This also comes with a 150 meters circuit length of sensing cable, but it comes with a 3-character LCD display, which means that if there is a leak, we will get to know the location of the leak in terms of meter or feet on this display. And this has also got a reset button. While designing a system, we can use a combination of the type of module that is best suited to the particular application that we are designing, and we can also do a mix and match of some of these modules to design an effective solution. So if you put all the components together, this is how the system is. The main control panel is the brain of the system. We can take up to 250 channels. We can do a mix and match of these channels. We can also include many third-party components. We can do extra relay modules if we need. We also have got a tie-up with Emerson. It's a global tie-up with Emerson, where Emerson has specifically developed a transmitter in its Rosemount range for BraceTech, wherein we can connect our sensors directly to the Rosemount Emerson transmitter, which can seamlessly integrate with our control units. And from an output point of view, the control panel is designed to give output to various host systems through Modbus, be it RTU or TCP. We can connect to SCADA systems, DCS systems, PLC systems. So all those kinds of integration facilities are possible, including VNC remote viewing, etc. So various connections to third-party systems are possible. Data logging and data entry is also a part of this control unit. I talked about third-party integration. So SCADA, factory automation, BMS, DCS, and PLCs are common systems where our systems integrate for different applications, be it commercial, industrial, or infrastructure applications. Let's understand how the system actually works, how water leak happens, what does the sensor do. So talking about these RAYCHEM stick circuit, it is basically a 4-core cable wherein we have 2 electrodes which are in the center, which are black in color, and 2 current carrying conductors. So the loop which is on the top, the red and black loop, is where the current normally flows in case there is no leak. The cable is installed in an area where leak should not be present. And whenever liquid comes in contact with this cable, there is a conductive path which is formed between 2 electrodes. So there is a change in flow of current from the first loop to the second loop. So when the current starts flowing in the second loop, that is, there is a voltage and current which is there in the second loop, which can be sensed by the panel. And simple Ohm's law instrumentation is used here. Resistance is a function of distance, and by knowing the resistance in the circuit, we get to know the distance from the starting point where the leak has happened. Electronically speaking, this is a Wheatstone bridge, and from the starting point, we get to know the exact location with a pinpoint accuracy of plus minus 1 meter. Say you have a system which is having, say, 500 meters of sensing cable installed. If at any point water touches it, the control panel within 2 to 3 seconds will know the exact location with pinpoint accuracy. So you don't need to run around and find where the leak is. You can exactly go to the point with pinpoint accuracy and carry out the necessary remedial action. The control panel has a proper event history to log the data with date, time, and create different types of reports which can be accessed for various maintenance purposes. So typically, if you look at the architecture of a system, we have the control panel. If we have a big area where water leak detection system needs to be designed, we can place sensing cables in those areas and connect our sensor interface modules to those areas. And in the end, those sensor interface modules can be wired back to our control panel through an RS485 bus, as illustrated in this image. So in a way, this is a system which is decentralized in terms of intelligence. As I said, these modules independently are capable of detecting leaks. All of these modules are mini panels. They are getting information from their respective sensing cables, and then ultimately they are wired back to the main control panel. So even if there is disruption in the signal between the modules and the control unit, the system will still continue to function. So many big projects where we have installed this system, for example, in the main Mecca Mosque in Saudi Arabia, the Haram building, we are doing the fuel leak detection system. We have several fuel leak sensing cables which are installed in different areas. We have got different modules installed in different areas, and they're all wired back to one main control panel. In case there is any leak anywhere, you get a local indication at the module, plus you get a central indication. And in case there is any disruption or if there is any break in the circuit intermittently, the system still continues to function, and it is independent of any connectivity issue as well. Overall, water leak detection system is a very, very low voltage system. Typically, it works on 12 volt DC voltage, which is very low in the electricity industry. And the total power consumption of the system is not even 5 watts when we talk of, say, 2 or 3 kilometers of sensing cable which is being installed. The tray stick system is a very versatile system. As I said, that this is used for different liquids, and we have different sensors for different liquids. So from one control panel or in one facility, if you're having server room, if you're having chemical storage, and if you're having fuel storage for DG set or electricity generation, we can use only one control panel, and we can dedicate different modules for different applications. Like the module on the top image is used for water leak detection system, the one in middle is for fuel leak, and the one at the bottom is for chemical leak. So 3 systems in one main control panel, you will clearly get to know where the leak is, which is the area along with the application. So it's quite a versatile system. You don't need to have 3 different systems for 3 different applications. So one main control panel will suffice it. In terms of designing the system, we can design the system in a way we can, as I said, we can go up to 250 modules. Each module can take up to 150 meters or 1.5 kilometers of sensing cable. We can do a combination of sensing cable and the probes on one circuit, depending upon how the requirement of the site is. We can use branch connectors to take branches from the sensing cable route as long as the sensing distance is met. So there are various design options in which we can do designing of the system to optimize and make the best use of electronics and sensing components. So this was a brief overview on our water leak detection application for commercial applications and what is the technology that we use and how it is implemented. I'll talk a bit about fuel leak detection systems in commercial buildings. And what we have is an FM 7745 compliant fuel leak detection system, which is used in commercial and infrastructure buildings. FM stands for Factory Mutuals. And Factory Mutuals was one of the first agency to introduce standards for liquid leak detection systems worldwide, and more so for commercial building applications. nVent RAYCHEM TraceTech system was the first system to meet all the requirements to qualify for FM 7745 standards. And these systems typically detect diesel fuel leakages from tanks, pumps, valves, etc., and fittings, which we normally use for diesel storage and diesel generators for electricity generation purposes in building. And these sensors, which are FM approved, our probes can give a signal within 30 seconds of a typical diesel leak which has happened. So what this technology for fuel leak detection is, what we have is a probe. In simple terms, the definition of this product is the moment liquid hydrocarbon touches it, it senses it and it gives off an alarm within a space of 3 to 5 seconds. So in a building, we typically have DG sets which are quite used for electricity generation in case there is a power failure. We do have storages of liquids in bay tanks, etc., sometimes in basements, sometimes at the roof of the building. And we also have piping networks in buildings from where fuel is transferred from these tanks to DG sets in various buildings. So what we have is this probe which can be placed along the DG set on the pad where the generator rests. In case there is any spillage or leakage from the generator, it would just come in contact with the probe, sense, and give off an alarm. So leaks are not only a safety hazard, but they are a big threat to a business community. They can easily convert into a fire. So it is, we do have fire alarm systems in a building to take care of emergency in case there is a fire. But liquid leak detection systems for fuel applications are one step before the fire alarm systems, so that they detect leakages which, if go unnoticed, can end up into a big fire. So TTFFS, known as TraceTech Fast Fuel Sensor, is the probe which is compliant with FM 7745 standards. We also have a fuel sensing cable called TT5000, which is also used for fuel sensing purposes. Talking more about the working principle of the probe is basically a RAYCHEM technology probe. It has got a sensor circuit board which is inside a PVC housing. The probe comes with a special polymer. It's a carbon-enriched polymer manufactured by RAYCHEM, which is sprayed along the sensor blade with a particular resistance in it. So when there is no hydrocarbon in it, there is almost zero resistance in the circuit. And when the probe comes in contact, or the carbon film on the sensor blade comes in contact with liquid hydrocarbon, immediately within a space of 2 to 3 seconds, this polymer tends to swell and the resistance increases. There is a particular threshold which has been set at which the probe gives off an alarm. So this is how the probe works. So once liquid hydrocarbon comes in contact with it, there is a change in resistance in the circuit. Once it reaches the threshold, it senses and it gives off an alarm. Once this probe is removed from the hazardous area or removed from the contact of liquid hydrocarbon, it is dried up in open air, washed with isopropyl alcohol or proper guidelines. This is reset to reuse again. Likewise, we have got a sensing cable technology which is used to detect different types of liquid hydrocarbons like diesel, gasoline, naphtha, jet fuel. All liquid hydrocarbon family members can be detected by this hydrocarbon sensing cable, including crude oil. It is designed to be installed on the floor in trenches, along with buried pipelines, overhead pipelines, double containment pipelines. So there are multiple applications where this can be used. It comes with a special technology. It has got a RAYCHEM carbon enriched polymer technology, which is selective absorption of liquid hydrocarbon. And once liquid comes in contact with it, like in the case of water leak detection cable, it senses and it gives off an alarm. So just to give you an overview of the fuel sensing technology, we'll do an anatomy of this cable. And this again is also a 4-core sensing cable. But the difference this has with the water leak sensing cable is that it comes with a special braid on top of it, If you can see in the middle, there is a special braid which is made of carbon enriched polymer, and this is where the sensing technology lies. Entire cable is jacketed with this carbon enriched polymer braid. And if you do, and this particular polymer, when it comes in contact with liquid hydrocarbon, this tends to swell. This swells approximately 200% its size. The conductive polymer in contact with liquid hydrocarbon swells and the size of the polymer increases. So let's understand what does this mean for the sensor. It is a 4-core cable like in the case of a water leak cable, and the polymer on top of it, when it comes in contact with jet fuel, it begins to swell. The braid on the outside is not allowing it to swell towards the outside, so it is swelling inwards, and it eventually comes in contact with 2 sensor electrodes. And this is how a conductive path is formed, and we get to know the exact location of the leak. So in case of water being conductive itself forms a conductive path between the electrodes. In case of fuel, we use this conductive polymer to swell and create a conductive path between these electrodes, and rest is the same. There is a change in flow of current, there is a change in resistance. Resistance is a function of distance, and you get to know the exact location. So typically in a data center today, we are in need of both the technologies. We use water leak detection system for the data center area where we are using cooling to cool the data center, or there could be a potential hazard. And we use fuel leak detection system for generators and diesel storage, which is used for emergency electricity generation. You can dedicate different modules for different applications, and they can all be wired back to one main control panel to make a seamless leak detection system. So talking of fuel leak detection system in commercial buildings, emergency power systems, dual source boilers, diesel fire pumps, main supply for fuel in basement, pump to deliver fuels to various floors, day tanks, fuel filters. These are all potential areas where fuel leaks can happen. And once a system is carefully designed, we can place a combination of our cable and probe sensors to make sure that if leak happens in any of these equipment in a building, it is immediately notified and with pinpoint location, and we can also initiate a remedial action if need be. I'll conclude this by sharing some of the images where we have installed our probes for different applications like day tanks, generators, fuel pumps, piping networks, filters, etc. So a combination of our sensing cables and probe together can make this function. This is an illustration of our fuel leak sensing cable for overhead pipelines. Like in the case of water leak, we also have fuel leak sensing cable with an overbraid technology on top of it. We can strap it at the bottom of, say, return and supply pipelines in case there is fuel leak. The same action happens, liquid comes in contact with the cable, and with the carbon polymer technology and swelling action, pinpoint location of leak is notified onto the control panel. I'll talk a bit about infrastructure and industrial solutions as well, because as I said, we do have solutions for infrastructure applications as well. So typically when we talk of fuel leak detection systems, we talk of tank farms and pipelines. We do leak detection system for under tanks if there is a new or an existing tank in a tank farm area, above ground tank areas, in case you have got pumps, you've got valves, you've got various fittings in a tank farm area where there is a potential for leak, we can use it there. Bullet tanks, buried pipelines, above ground pipelines, BG sets. So fuel leak detection systems can be used for all these infrastructure and industrial applications. Water besides data center we use for a wide range of applications like airports, stadiums, tunnels, infrastructure projects, etc., railways. Chemical leak detection system for storage of different types of chemicals in industrial and petrochemical industry, pipelines, tanks, etc. So these are the different applications wherein we use our systems for infrastructure and industrial use. For typical buried pipeline applications, the sensing cable that we have comes with a special braid on top of it. This is just to make sure that we are able to pull this cable in and out of the buried pipeline. So there is an extra white layer of polyethylene rope which is braided on top of this cable. This increases the braking strength and it causes much less friction in a conduit. We use a special conduit through which this cable is installed. The conduit through which we install this cable is a slotted conduit. This has got slots all along its length. We place the sensing cable inside. In case there is a leak, liquid would come in contact with this conduit. It will ingress through this conduit, come in contact with the sensing cable, and it will give off an alarm. So the sensing cable installed in a slotted conduit, which is then put adjacent to the product pipeline. As you can see in this illustration, we have this blue conduit lying along the product pipeline. Whenever there is a leak from the pipeline, it would come to the conduit, and through the conduit in contact with the cable, and the cable would sense and give off an alarm. So these are some illustrations of our fuel leak sensing cable being installed for infrastructure applications in airports, fuel hydrant pipelines. We have the cable which is installed along the pipeline in these conduits. We've also got pull boxes at regular intervals from where we can access these cables. So typically at around 250 meters, 250 to 300 feet, we install these pull boxes from where these cable can be accessed for any maintenance purposes, etc. This is how a typical architecture of a buried pipeline would look like. We'll have the main control panel and the module, and this module is connected to the sensing cable. We'll have the slotted conduits installed along the length of the pipeline, and we'll have the pull boxes at regular intervals so that we can access the cable, remove the cable, or put the cable back in case we need to carry any maintenance. So we can do several kilometers of these installations. We normally don't do this for very long pipelines, say 100 kilometers, 200 kilometers, but for specific applications up to 20, 30, 40 kilometers, typically seaports, airports, pipelines within a refinery, or select pipelines where location accuracy is of importance. Pinpoint accuracy and early leak detection is important. Those are the application areas where we install this for pipelines. Some more illustrations of cables being installed for pipelines. Here, these are existing pipelines where the customer wanted to install sensors, sensing cables, and leak detection systems. Since we can pinpoint the location of the leak in one of the projects for multiple pipelines, one sensing cable has been used. All the pipelines are carrying liquid hydrocarbon. Whenever there is leak, we will get to know the location of the leak. We might not know which pipe is leaking, but since we are optimizing and using one sensor for multiple pipes, we'll still get to know the location where the leak is happening, and we can get there and find out the exact source as well. Some more images of sensing cable buried in some installations. This is a fuel hydrant installation at an airport in Spain. The groundwater level was quite high there, so we used a polyethylene sheet to wrap the product pipeline and the slotted conduit with sensing cable, so that if there is a leak, it would remain contained inside the polyethylene sheet, and an early detection would happen. Some more images of sensing cable being installed in conduits for buried pipeline applications all across the world. A typical architecture diagram of a large project where this is an architecture diagram of Abu Dhabi International Airport, where we have installed 60 kilometers of our fuel sensing cable for leak detection system. So we made multiple enclosures having somewhere 7, somewhere 8 SIM modules. All of them were strategically placed at different locations at the airport. Sensor interface modules had the sensing cables connected. They were all then connected on a fiber optic network back to the control panel. So if there is leak anywhere on the fuel hydrant line of the Abu Dhabi airport, our system will be able to sense it and give the exact location with an accuracy of ±1 meter. And this means a lot for the customer, because in an airport kind of a scenario, we cannot afford to dig, or we cannot afford to dig the runway and stop the air traffic or cause disruptions. And more importantly, we need to know the location so that we are exactly able to go to the location and carry out remedial action. We don't need to actually dig a large area and find out where the leak is, or we guess where the leak is. Similarly, for the probe in the industrial and infrastructure project, it's used in refineries for tank farm safety monitoring. Sometimes it's used on tank roof in case we are using a floating roof or a tilted roof kind of a scenario. Tank bund areas on the tank bund wall is one prominent application area. Wastewater monitoring, sometimes hydrocarbon is present in wastewaters. Oil water separators in a tank farm is another application. Hydrocarbon shouldn't be present at the end of the separator. So this is one area. Petrol filling stations, we have those underground tanks in all the petrol filling stations, and they're all buried. So sometimes if there is a leak which happens, it might go unnoticed. So various petrol pumps in the US and China are having our probe installed for leak detection system applications. So typically, if there is an overfill or there is a leak from the side of the tank, which could be through valves, or there is a rupture in the tank wall, if there is a leak on the roof of the tank, which can eventually result in fire, so we can place our sensors there. There is a drain which carries the rainwater. In case hydrocarbon is mixed with rainwater, this probe can sense it. It completely ignores water, and it can be placed in outdoor environments as well. So this is used to sense hydrocarbon leak detection systems in water bodies as well. Some images of our sensor being installed on the tank bund area. This is a water drain around the tank. We can install the probe on the water drain. In case hydrocarbon is floating on it, it would be sensed by the probe and it would give off an alarm. This is an inlet valve. In case valve tends to leak, hydrocarbon comes in contact, few seconds, and we'll have the alarm. In pits, we place the probe on a float assembly because the hydrocarbon having density less than water normally floats on the surface of water. So putting this on a float assembly makes the sensor at the level of the hydrocarbon. So as the level of water goes up and down in a pit, the sensor also goes up and down so that it maintains itself with the level of the water in the pit. So various applications we can use our sensing cables and our probes for environmental spill applications, be it refinery, tank farm, or any other inaccessible areas where hydrocarbon should not be present. Talking of approvals, our systems are having all international approvals. This probe is a SIL 2 device, safety integrity level 2, so it is highly used in areas where we are using SIL 2 rated PLCs. It's having all international approvals like BASIFA, safety integrity approval, EXD approvals, and temperature ratings, etc., approved by FM Global as well. Last but not the least, talking about tank bottom leaks. So tank farms today are quite common, and fuel leak detection normally from the bottom plate of tank completely goes unnoticed, even for longer duration of times. So what we do is we place our fuel sensing cables at the bottom of the tank in a parallel mesh kind of a scenario. So what we do is the same slotted conduits that we use for the pipeline applications are now put at the bottom of the tank at a spacing of around 4 meters, and we place our sensing cables in there. So in this image, the blue circles are the conduits and the black dots are the sensing cables. So whenever fuel leak happens from the bottom of the tank, it eventually tends to grow, and it comes in contact with one of our sensors, and the swelling action happens in the cable. The polymer swells, the electrode forms a conductive path, and eventually we get to know the leakages happen much earlier than otherwise we would have come to know had there been no early leak detection system installed. And that is the basis why this has been used in various tank farms worldwide today, including the United States, Europe, Middle East, and we have done some of it in India as well. A typical architecture diagram of a hydrocarbon leak detection system from a tank bottom. We'll have cables in a parallel mesh, and they will be connected to the sensor interface modules. And like in the normal cases, the sensor interface module will then be wired back to the main control panel. And we'll not only get to know the that leak has happened, we'll get to know on which segment the leak has happened and at which meter the leak has happened. So the accuracy of the system is very much precise. This is an image of a SCADA, a screenshot of SCADA from one of the ADNOC projects in Abu Dhabi, where we've installed leak detection system for a fuel hydrant line, and the entire line is monitored. Entire circuit length is available on the SCADA. In case leak happens in any of the circuit, you get a red indication with the location in meters so that necessary action can be initiated without wasting any time. We also do this for existing tanks. We can, if you're not able to put the cable in the foundation of the tank in a parallel mesh, we can do it on the perimeter of the tank in a circular fashion so that in case there is a leak, it is coming out to the perimeter and it is sensed by the sensing cable. and you get an alarm. Although there might be a delay compared to when we install it directly below in the bottom plate. But then for existing tanks, this is the ideal way we normally do leak detection system. I mentioned earlier, Emerson has developed a special transmitter, and we have a tie-up worldwide with Emerson, wherein they have developed in their Rosemount range a transmitter, wherein our sensors can be directly connected to their equipment. We don't need to have any of our modules, etc., in between. So our sensors and sensing cables can directly be connected to Emerson wireless transmitters. These Emerson transmitters communicate over a wireless HART network to the receiver in the control room, and data from the receiver can then be retrieved back to one of our control panels, and it can be displayed there. So for those facilities where wiring is not an issue, typically for existing tank farms, we can place the sensors through these wireless devices. They draw the necessary required power from these from the batteries of these wireless devices. So typical application could be tank farms or tank roofs or areas where wiring from the sensors to the control room is not possible. These transmitters are having a high design life, and their battery life typically lasts around 8 to 10 years. So they are quite efficient, and we have quite a significant installations for wireless leak detection systems worldwide as well. To talk about one of them, this is the layout of a big tank farm project that we did in Kuwait. This is for KNPC, where we have installed wireless leak detection system in a big way for these tanks, for existing and underground one, all connected over a wireless mesh network. So around 16 kilometers of, 6 kilometers of sensing cable and around 54 probes, all communicating to the control room on a wireless network. Well, before I conclude the presentation and show you the references, one thing I want to mention is that nVent not only just manufactures these solutions, we also provide integrated services. For example, engineering services, project management, field construction, procurement, commissioning, site services, post-installation, and quality assurances as well. We have a complete design team based out of India and the Middle East, wherein we have a team which is capable of making a proposal, designing these systems, carrying out all kind of field services. These are all niche product lines, so we provide all the necessary support in not only manufacturing our products, but also making sure that they are properly implemented at the site with all these necessary supports. One of it is making these custom control panels, which are best suited and customized to different project requirements based on the design that is being done. So all those options are